So now that we've covered the main features of quadratic functions in the previous video, we're going to get into drawing these and sketching the graphs on a Cartesian plane. Now, looking at this graph here, all we're going to do is, similarly to how we've done our exponentials and our linear relationships before that, we are just substituting our different x values into our rule to find a few y values, plotting the points, connecting them, and drawing our graph. So I'm going to substitute a few of these values in and go straight into it because we've had plenty practice going in and completing a table of values. So substituting in -2 gives you -2 squared plus 1, which gives you 5. Next one, we put -1 squared plus 1 gives you 2. 0 squared plus 1 gives you 1. 1 squared plus 1 gives you 2. 2 squared plus 1 gives you 5. So you can already see, remember we talked about these have an axis of symmetry? We can already kind of see this kind of playing out, right? We have a graph, it goes down to 1, then it goes back up the same way. So we're already kind of predicting the shape here. So when x is -2, y is 5. That will go up here. When x is -1, y is 2. When x is 0, y is 1. And it goes back up like this. And you can see we've already got the general shape. We can see that there's an axis of symmetry around the middle, and the graph has been shifted up, it looks like. It's not the simple y equals x squared graph, but as we talked about the transformations before, this number is going to bring it up a little bit. So we're going to try to connect these with one continuous curve, and we get our graph. I'll just draw arrows on the end just to show that it continues in both directions, and I'm going to label it. So I have y equals x squared plus 1. Now this has all the features we talked about before. The 1 shifts the graph up so that now the y-intercept is at 1. The coefficient in front of x squared is positive. It's positive, so it's going to be one of these parabolas that looks like this with a minimum turning point. Now I'm just going to label the minimum turning point because you want to just show all of your features. So the minimum turning point is at the coordinate 0, 1. So we're filling in our table of values and just sketching up our parabola. Now next one, we are going to draw the graph using a table of values, and we are going to label and identify all of these different points. So substituting all these in, you can pause the video and have a go at doing these yourself, but I'm just going to go through and just sub in now. So subbing in -1 for x gives you 8. Subbing in 0 gives you 3. Subbing in 1 gives you 0. Then -1, 0, 3, and 8. Okay, so this is the table of values filled out. Now we want to plot our points. So we have -1, 8. So -1, then 1, 2, 3, 4, 5, 6, 7, 8. We have 0, 3. We have 1, 0. We have 2, -1. 3, 0. 4, 3. And 5, 8. So we can clearly see that shape happening again. So now that we have all of our points in, we just have to connect this with one continuous curve. So we want to pass through all our points. And we get something that looks like this. It'll take a little bit of practice. These are tricky to kind of sketch out, but we have our graph, we label it, y equals x squared minus 4x plus 3. And now we want to identify all the main features. So our turning point is down here. That's at the coordinate 2, -1. So our answer to A, our turning point is 2, -1. Now, our axis of symmetry lines up with the turning point. our turning point actually lies on the axis of symmetry. And that kind of makes sense, right? Because the graph has to go down. Where it turns, that's where it starts to get reflected. So I'm going to label in my axis of symmetry. And the equation of this is a vertical line. So it's passing through an x value of 2. That lines up with this coordinate. And this is just the vertical line of x equals 2. So the equation of the axis of symmetry is x equals 2. Okay, next part. Our y-intercept. An intercept is a key feature we should label as well. So the y-intercept is going to be 3. So our y-intercept is 3. Next, we want to find our x-intercepts. These, just looking here, it passes through 1 and it passes through 3 as well. So the x-intercepts are 1 and 3. Okay, and we're looking at the last part is just asking for a minimum value. That's just asking what is the minimum y value? Essentially, how far low does, what's the lowest possible the graph goes? So here, looking at the minimum value, that will clearly be present in our minimum turning point. So we're looking for how low the graph goes. The minimum value is -1. So this is how we can sketch our graphs, our quadratic functions, using a table of values and identify all of the main key features. So remember, we have to label our graph, we have to label the vertex, label the axis of symmetry, our y-intercept and our x-intercept also. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.